learn about boilers? Why should I worry about boilers, furnaces, thermic fluid heaters as an electrical engineer? I have nothing to do. But later I understood that you will not become an engineer if you really don't understand how the other faculties are functioning. That's the main difference between engineering and medicine. If you go to a doctor and say that I have headache, he will never say that I have not learned headache or I have not learned fever. That is not my subject. That was not my elective. But this happens quite often in the case of electrical or engineering subjects. If you go and talk to an electrical engineer like me and talk about boilers, I would say that that's not my subject. That is where I think you need to take a quantum jump or change yourself, your attitude, that you must learn about uh, all other faculties of engineering. Otherwise, you will not learn anything about energy. So this is just an intro. I just want to bring you into my major topic of energy conservation, management, and climate change. And let me start with the end game. That is the last word, the climate change. If you have learned chess, I know that how important the end game is, and that is where the pawns are becoming very powerful. They can protect the king. They can even become a queen or a rook or a bishop. And people like us who are the pawns in this, we don't have power. We are not controlling. But at the end, when we are reaching the end game, we are the people who are going to decide the future. That's why you people are really, really important here. And now there is a consistency in the models that the climate change produced by IPCC, which says that Asia, one of the most populous regions, would translate into more floods, landslides, intense rainy seasons, and droughts. There is absolutely no doubt about it, and we are also part of it. And people in Kerala have really understood it after 2018. So whatever development what we talk about in Kerala after 2018 must be different from what we were thinking a few years back. And that is applicable to almost all the places. That it's There is no doubt that the climate change is going to affect the entire population. And it's not just floods, but it's also more unpredictability of water cycle. You are going to have as many number of droughts, as many number of floods. And this is not my own words, it's by from Oxford University. He said that it's not just floods. The total unpredictability of water cycle is what we are going to face in the coming years. And if you understand this, then you will understand why we are talking about energy and energy conservation. Then you will understand why we have to manage energy. It's much beyond that what you learn in your textbooks of thermodynamics, the first law, second law, or thermodynamics. It's much, if you don't understand this connection, this nexus between energy and climate and our own living, then you will not understand whatever that you're learning from the textbooks. So to mitigate or adapt to the impacts of climate change, we should know the energy environment climate change nexus with all its intricacies and uncertainties. That's more important. You are going into a world where you have more uncertainties than certainties. Especially people who are talking about, for the computer science students, I'm telling you, you are going to jump into a world of big data where you have millions and millions of data coming out, and most of them have got these uncertainties, and from that you have to find out how the climate is going to be changing tomorrow. It is not easy at all, and it is very intricate, and we are filled with uncertainties, and we don't know what is going to happen tomorrow. You cannot predict whether you're going to have a flood in 2022 August as it happened in 2018 and 19. And that is where the challenge also for the engineers. We are living in a crisis of global heating, which poses a great threat to the well-being of the global population that will exceed 9 billion people by mid-century. It's not a small number. It's going to affect almost 9 billion people. At the same time, there is a great opportunity to reshape our production and consumption systems. That is where you people, the young people, have got a challenging role. Every one of you, whether you are a civil, mechanical, electrical, electronics engineer, you have a role to play. And you must understand that why you have to do that. And that is for the survival of the entire people around the world, and not just for this country or a state. So when we talk about energy, gently people get misguided thinking that energy is just electrical energy in your house or that runs the industry. No, you must understand how the energy cycle in the entire earth system is happening. And if you don't understand that, you will not understand this connection between energy and ecology, or energy and environment. uh, these things are available on the net. I'm not going to the deep, but I'm just telling you that most of the energy that is coming to earth is from solar energy, and some of them are getting reflected back, and some of them are returning back because of the greenhouse gases. I'm sure that you know about all these things, but it's all about the balance between what is coming in and what is going out. And if the entire energy that is coming onto the earth is reflected back, then we will not be able to live in this world. It will become another ice age. We are living in this world just because of we have some greenhouse gases in the atmosphere. But what will happen if its content goes beyond a limit? Just hold on a second. I'm ഒരു മീറ്റിംഗിൽ ക്ലാസ് എടുത്തോണ്ടിരിക്കുക. Sorry. Yeah. So that is the pink arrow shows that incoming energy flows to the earth, and the blue one what is going out, and some of them are getting reflected back, and that is why we are able to live in this world. But the problem is that if the greenhouse gases goes up, the average temperature you can see here from 1885 to 2020, around 2020. During 1885 to 1945, the average global temperature was hovering around zero point 0.5, minus zero point 0.5 to plus zero point 0.5. And it was not going much different. But after 1985, this graph shows that the average global temperature is going up steadily and steadily and steadily, and it has reached the maximum at 2020. Here you can see only up to 2015. And now it has reached almost 1.5 degrees centigrade. Here I'm showing the left is Fahrenheit, but if you move beyond 2015 to 2022, we can see that the average global temperature has gone up by 1.5 degrees centigrade. So you might wonder, what is this 1 degree can make a change? You are sitting in this conference hall. I'm sure that it must be an air conditioned hall where you have set the temperature somewhere around 24, 25 degrees centigrade. The moment you go out of that hall, it will become 28 or 29. So what is this big thing about a 3, 4 degrees centigrade change? Nothing is happening to us. No, that this is the global average temperature, and not just a temperature at a particular location. And just think about one thing. As an engineer, you know that if the temperature goes up in the atmosphere, the air will expand. And if the air expands, if the temperature goes up by 1 degree centigrade, the air will expand by around 10 to 15 percentage higher. It can hold more water. If the average temperature of the oceans increases, it will increase the precipitation. So there will be more water coming from the oceans, and the atmosphere will be able to hold more water, and so your rain patterns will change. Now you can see that all our rains are something like a cloud burst. It has called sudden heavy rains, and it vanishes after some time. Earlier it was not like that. In Kerala, we had some drizzling rains continuing for 5 to 6 hours continuously, but in the last couple of years, you will not see those kind of rains. So why this is happening? It's because of the 1 degree centigrade change. Or if you give another example, the temperature, yesterday there was a news saying that the Bengal Ocean, the temperature has changed by 1 degree in the last 10 years. The Arabian, I can show you what happened in our Arabian Sea by changing in 1 degree centigrade. Why it is? Because if you talk about the global warming, only the 7% of the heat is being trapped by is sticking around the surface and the atmosphere. 93% of the temperature or the heat is absorbed by the ocean. And now it's almost saturated. Any increase, it's going to make a huge difference. And what is going to happen when the temperature goes up? You just see this graph, only 2021, all these dotted lines are the typhoons or the hurricanes that came around the Arabian Sea and the Bay of Bengal. A few years back, we had all these depressions and typhoons and tornadoes coming only in the Bay of Bengal. But now you can see as many number is happening in Arabian Sea because the temperature of the Arabian Sea has increased by around 1 degree centigrade, just by 1 degree centigrade. And if you want to learn more about it, there's a lot of things available. I'm not going to the deep, but just watch some of this, like the cyclone Gulab, which started from the Bay of Bengal and moved across the entire continent and came to the Gujarat area in 29 September, 3rd October 2021. So this is something that has never happened in the past. Normally, what is happening when the landfall happens, that its power reduces and it stops there. And we had that Gaja that came a few years back that crossed the Western Ghats and came to India from the Bay of Bengal. So mind you that whatever that people are talking about of climate change, it is making a huge change in our living system. And we have seen the monsoon changes in monsoon, the cyclone Taute, what is happening due to the low pressure, how the rain patterns are changing, why Kerala had two floods in 2019 and 20, and Kerala had a big drought in 2015. So all these things are a result of the climate change that is happening. And now you have to ask who is responsible for that. And that is where the importance of this seminar. Before going to ask who is responsible, I think you know about the impacts of climate change. Warming of ocean raises the water level, combined water, melting glaciers, warming ocean water threatens marine ecosystems, and also increase the number of occurrences of severe cyclones. This we have discussed. This is something we went to Kumbalangi in 2022 February. This is, I think some of you might be knowing this place or belong to this place. This is at the middle, at the around 11 o'clock, 11:30 in the morning. You can see that water logging, and this person who lives in this house had to walk on these stone walls to reach his house. And more than 150 houses in this area are affected daily by tidal floods. Water comes in and goes out 2 times in a day. They can't even go to the toilet. They can't stand in their kitchen. They can't use their houses because of tidal floods. And one reason is that the level of the ocean has gone up, and there are so many other reasons of the developments that what we have learned. Hello, hello. Am I audible?
Yes, sir, you're audible.
Yeah, okay. There was some noise coming in between. Okay. So don't think that this is something that is happening in the Arctic or Antarctic. It's happening in our own place, just in our neighborhood. The climate change effects. If can you believe 150 people having water coming in and going out twice in a day, and the children there can't go to school because of every day they have some itching or some skin problem because they are living in water, and there are a lot of other issues. And this is, if you, it's not just in Kerala, not just in India, world across, the small island nations such as Kiribati, Tuvalu, or Marshall Islands and the Maldives would be literally wiped off the map. Maldives are trying to buy land in other countries, other continents, because they know that they are not going to survive after 10 years. And in parts of Jakarta city, the 9.6 million people, the ground has sunk 2.5 million in less than a decade. So these are all not just numbers, it's what's happening around the world. And who is responsible? That's where we have to start this seminar. Energy. 73 percentage of the contribution of global greenhouse gases comes from energy. Let it be from industry, let it be around 24% from industry, around 16% from transport, and 17.5% from building. So now, my dear civil engineers, don't you think that you have a big role to play in reducing this greenhouse gases, because you contribute 17.5% of the greenhouse gases? My dear mechanical engineers or computer science engineers or electronics engineers, don't you think that you have a big role to play when the transport sector contributes around 16.2%? We are going to change into a world of electric vehicles where the electronics and computer science engineers have got a big role to play than the mechanical engineers. And the mechanical engineers have to play a big role to understand that now we are shifting from IC engine to an electric vehicles. What is our role to play? And energy use in industry, every one of you, whatever may be your branch of engineering, you have a role to play. And this energy contributes around 73 to point percentage of energy contributes to global warming and greenhouse effect. And that is why we have to learn, we have to understand, we must have some insight, we must have some knowledge about energy conservation and its management. I hope that the premise is set clear that why you are here. The basic objective is to make you aware that we all, each and every one of us, whether we are a teacher or a student or an agriculturist or anybody else, we have a big role to play in making this world livable for the coming generation. And if you split up this greenhouse gas emissions by economic sectors, we can see that uh, electricity and heat production contributes a maximum of 25%, agriculture and forestry around 24%, industry only 21%, transportation 14%. And at the same time, if you look into the gases, carbon dioxide is the maximum 65%. But this doesn't really give you a correct picture, because if you take methane, which is only 16%, methane is 25 times more global warming potential than carbon dioxide. So, not just by numbers, the actual effect of global warming, if you want to analyze, then nitrous oxide and methane has a big role to play. Even their percentage contribution is less. And don't just get confused by this graphs with so many dots and dashes and colors. This is from an IPCC report, Peters et al. In Natural Climate Change. This is showing some representative concentration pathway, what will happen to our world in 2015 by different representative concentration pathway. For example, if you are adopting more EVs, if you are more adopting, shifting to more renewable energies, if we are not using coal, what is that actually going to happen? And if we don't do that, so this red line is something called an RCP 8.5, which shows that this is what is likely to happen if there is no a big change in our energy consumption pattern or energy producing methods. So it says that it is going up, and the average global carbon dioxide emissions is increasing like anything. And what we did is that, not just looking into the graph and sitting baffled, we did an analysis. It's an analysis with running in multiple programs on using supercomputers of data that is available the world across. Myself and my colleague Dr. C.G. Madhusudan, and we did an analysis to find out where we stand in terms of CO2 emissions on 8 January 2021, which shows that the carbon dioxide in ppm was 415 ppm, which is much beyond the worst scenario predicted by the IPCC, which is the RCP 8.5. So we are above the worst scenario actually, and this is where the engineers like you have to do this your analysis. You must go and study what is actually happening and what is these studies, and then we will understand that these are not just a tale that is told you to fear you that there is no development should happen. No, no, the changes are really happening, and we can see that the CO2 has gone up by around 415 ppm. And the level set by IPCC in the earlier days was we should not allow it to go beyond 400. We already crossed that limits. And there are, if no changes are happening, this is again going to go up and up and up. And one more thing that we want to tell you about the energy. When you're talking about energy, don't just confuse that electricity is the major contributor of energy. No. To see this graph, apart from service sector, nowhere electricity is a major contributor. Take the case of industry, electricity contributes only 16%. 36% is coming from coal and 23% from oil. Take transport, 95% is coming from oil, natural gas, uh, whereas only 1% is coming from bioenergy and waste. Residential, 68% is coming from bioenergy and waste, and only 14% is electricity. So those who are confused that the moment you talk about energy conservation, energy management, it is an electrical engineering subject, you are totally wrong. Uh, Only its contribution is very, very low, only 17% in total, whereas the contribution from oil is 33%, coal is 17%, and natural and bioenergy and waste is around 27%. So, and talked about the reserves to production ratio in one of my slides earlier. If you look into coal, the reserves is around 332,000 tons and production is around 730 tons per year. So that means it will last for around 942 years. And oil, sorry, consumption per year is around 942. Uh, and these figures will tell you how much the reserves to production ratio can last, and all these things you can get it from source of India statistics data. I'm not going to the details now. uh, I just want to move away from the numbers because I know that numbers and graphs are not really very interesting for anybody to listen to for a long time. So let's discuss something that is the myths and realities about energy and its sources. One thing that we need to immediately change in our textbooks, right from school to the engineering textbook, is that we are classifying solar and wind as non-conventional sources. It's really non-conventional. Vasco da Gama traveled in 1498 all the way using solar and wind. And we are talking about the oil sources, that the oil and other things that came in only at the end of 18th century as a conventional source. And we are classifying solar and wind as non-conventional. The first thing that we need to do is we must change this classification. If you don't change it, you will not understand it correctly. For example, if you are classifying people as people who are affected by COVID and not affected by people not affected by COVID, then if the classification is wrong, your entire treatment methodology will change. Similarly, if you don't really properly classify energy sources, then you will not be able to find out a solution. Solar and wind are not non-conventional, first of all, and there is no meaning in classifying it as conventional and non-conventional. What are you going to gain? What is the more additional information that you are going to get by classifying it as conventional and non-conventional? Nothing. You can't say that just by becoming conventional it is good or bad. Just by being non-conventional it is good. No. So first we need to understand, we need to change that classification strongly in our mind from conventional to non-conventional to either renewable and non-renewable, or a step ahead, sustainable or non-sustainable. Why I'm stressing it is that all renewables are not sustainable. That we'll discuss in the coming slides. So it's not enough that we change our sources to renewable energy, because all renewables are not sustainable. So we need to classify energy as sustainable and non-sustainable. And another thing that we always hear is there is nuclear energy, which is green. That's a big question that we, as engineers, we need to ask. How can nuclear energy be green? First, right from digging out the sources for its uranium or plutonium, then if you go into a little different analysis, what is the global warming potential of nuclear energy? Have you noticed the photographs of nuclear power plants across the world? The first thing that you will see is big cooling towers. What is the role of a cooling tower? It collects heat from one area and rejects it into the atmosphere. So these nuclear power plants actually reject a lot of heat into the atmosphere, either to the air or to the water. And how can you say that it is not heating the globe? And if you make a calculation, you can see that a nuclear power plant, say around 500 megawatt, will reject 2.5 times more heat than a similar coal power plant. What does it mean? Nuclear power plant directly heat the environment, and coal power plant produces carbon dioxide and makes that greenhouse gases indirectly heat the atmosphere. So you cannot call nuclear as a green energy source because it directly heats the energy source, and this is where we need to change our concepts about, and a lot of other issues like its safety and security and other things. Recently, you must have seen what happened in Ukraine when Russia attacked the Chernobyl area. Another point is that large hydroelectric stations is considered as a renewable green energy. And only very recently that large hydro has been put into the renewable basket. And that's why you can see in the the Glasgow summit, we said that we have achieved 175 gigawatt of renewable energy, but it's not just because we have achieved everything immediately. We have added around 65 to 70 gigawatt of large hydro into the basket of renewable energy, and we claimed that we have reached that 175 gigawatt. Although we have with solar and wind, it's only 100 gigawatt, and we added large hydro into the basket. It was not there until 2019. Large hydro was not a part of renewable energy until 2019. Then we changed, and now even after that, if you see, the large hydro generation is not free from greenhouse gas emissions. So that's why I said all renewables are not sustainable. And there are people who still believe that oil is going to last for another couple of centuries. So these are all the myths that we need to debunk the myths, and we need to discuss more and more about it and understand when we are talking about energy and energy conservation. And even today, that people are really confused with global warming and climate change, which are not synonymous. We must understand the difference between global warming and climate change. And also, there are talks when I hear people talking about ozone layer depletion causing global warming. So we must also understand the difference between what is happening due to ozone layer depletion. And these are some of the myths that we can learn and discuss and understand a little bit more when we are talking about energy and energy conservation. And this is something not from detailed study about the large hydroelectric power plant. I'm just putting these quotations for you to think more about it. It says that dams disrupt the natural ecology of rivers, damage forests and biodiversity, release large amount of greenhouse gases, and displace thousands of people while disrupting food systems, water quality, and agriculture. The human cost of large dams are no less important as the social, behavioral, cultural, economic, political disruption that populations near dams face and routinely underestimated by Maureen Maria Claudia Lopez. Even today, I saw a Facebook post when people were vehemently arguing that those who talk about against the large dams are anti-development. And they say that we all have developed only because of the dams across us, but we have never really gone into the damages that is happening across the people who are rehabilitated from that place, or what is happening into the normal flow of the river itself, how much biodiversity we have lost. All these things are to be counted when we are talking about the solutions in the future. We cannot blindly accept that this is good and this is bad. I'm not saying that this is totally bad, but we must understand the other flip side of this. Just because of renewable, it doesn't really become a green solution for most of us. And another important finding is that the reservoirs built for hydropower generation have been identified as a significant carbon dioxide and methane contributor. Have you ever thought about it? It's not just that the smoke coming out of the coal power plants are contributing greenhouse gases. The big reservoirs of the dams contribute much higher than that. And I told you that methane is around 25 times more powerful than carbon dioxide. So the bubble-based emission analysis, the researchers found that the dams emit more methane than lakes and wetlands. So it's not just the lakes and wetlands, not the paddy fields. Paddy field can be a net absorber, not a net emitter, depending upon the type of cultivation that you do. But the dams are always a net emitter of methane and carbon dioxide. That's why we said that when we are talking about renewable, we need to be a little more cautious about talking about large hydroelectric power plants. And there are also reports saying that the fifth assessment report of the Intergovernmental Panel on Climate Change, which calculates methane as 34 times higher. Sorry, I told 25. 100 times time horizon. And there is no doubt that harnessing and managing power of water is critical for economies, but large dams are not the way to do so unless suitable risk management measures are carried out. It's by answer and native. And why the risk management? You look into the data of the US Army Corps, which says that US has found 1,800 non-federal dams and 275 federal dams are unsafe. In Kerala, we have been talking about that Mullaperiyar Dam for a very, very long time. And removing a hydro dam could even cost more than building one, especially when reservoir sediments contain heavy metals and toxic contaminants. So decommissioning of hydroelectric power plant is something for which a solution is yet to be found out, similar to what is the nuclear. We don't know how to decommission a nuclear power plant safely. We don't know how to decommission a large dam safely even today. So this is a challenge for all the engineers sitting there, the civil engineers, the mechanical engineers, the electrical engineers, everyone. And mining and extraction, in the case of nuclear, it produces greenhouse gases. And also, the decommissioning cost of a nuclear power plant is substantially high. And Germany has decided to phase out nuclear power plants in the next 5, 6 years. And UK is also decommissioning 17 nuclear power plants. Why I'm stressing on these two, the hydroelectric and the nuclear, because these two are projected in front of the world as the solution for reducing greenhouse gas emissions and the solutions for our energy crisis. France, which is the biggest producer of electricity from nuclear power plants, has set up around 23 billion to decommission 58 reactors. When the entire world is thinking of decommissioning their reactors, this is not the right time for us to think about a new nuclear power plant anywhere in India or in the other parts of the world. I will try to bring you a few more aspects of how we are going to decide what are the future energy sources. So when you think about what are the future energy sources, don't just think about the capital cost. Capital cost can be totally misleading if you don't really understand what is the embedded energy in it. That we'll talk about later. And we also should understand what is the running cost and what is the environmental cost and what are the social factors, the availability, accessibility, affordability, all these things. I think now it is very easy for you to understand the moment we are discussing about a big development projects coming in Kerala. Every discussion is hovering around two aspects: the environmental impact assessment and the social impact assessment. So any development, any new sources that we are coming, we must actually understand the environmental impact and the social impact, and then only we can decide that this is going to be our future solution. It can be a small developmental project or to any big projects. And earlier days we were looking only into how much money we had to put in as capital. Now the world has changed because we are more aware about what is development. It is not just infrastructure building or producing more and more power plants or producing more energy. Energy development is not directly proportional to the amount of energy produced or consumed. And also, as a part of environmental impact assessment, we need to understand what are the greenhouse gases, what is the particulate matter exposure, what is the freshwater ecotoxicity, what is freshwater eutrophication, and what is the land occupation. Recently, I heard a very disturbing news from the north of India, where a big private company has deforested, cut down thousands and thousands of trees to put solar panels there. I really didn't understand the logic behind this, cutting forests to put solar and saying that we are producing green energy. And recently in Kerala also, there was a report that Kerala State Electricity Board is cutting 417 trees in Brahmapuram to put up solar photovoltaic panels there. So this is where we need to actually understand the environmental impact, where the land occupation, what is the value of the land, and which is more important. And also something quite often ignored are the demand for materials. It is not the energy sources that are going to extinct in a few years. The more the materials like aluminum, copper, iron, cement, cadmium, nickel, all these things are required for your renewable energy also. If you want to make a solar photovoltaic panel, you want this material cadmium, nickel. If you want to make a wind turbine, you require large amount of cement and metal, iron, and copper is absolutely required for carrying out any electrical or transmission of energy through electricity, aluminum and copper. So what will happen if these materials are getting extinct? Whatever, whether you produce energy through renewable or non-renewable, and if you are not successful in getting these materials, then that will also affect our energy security. So it's not just about the reserves to production ratio of the oil or the energy sources that is more important. It's important to understand that some of the materials are also getting extinct. So we need to, there's a huge challenge for you people, the young generation, to study about this, how much effect is going to happen in the coming days. So just 1 second. Now, I'll just give you an introduction about energy auditing. I'm not going to deeply into energy auditing, but I will tell you that this is an area where you can actually do your final year projects in a very, very effective way. Any branch of students can do take up an energy auditing as your final year project, and that will really give you an insight about what is energy conservation and management, and also help you to reduce your own bills at your house. So I'm not going to talk to you about the energy conservation in industry, though that is there in your syllabus. I'm just taking you through how you can make this energy conservation at your home. Then you will understand how you can and why you should do it in an industry. So before going into it, I'll just give you a brief idea about there are different types of energy audits. Uh, I'm a certified energy auditor. Uh, Actually, I've been doing energy audits since 1998 and became a certified auditor in 2005 when the Bureau of Energy Efficiency conducted the first national exams. You all have that potential, or you can write these exams once you complete your engineering and have a couple of years of experience. There are different types of audits called a walkthrough audit, where you can just walk around the facility. If I'm going to do a walkthrough audit in your college, it takes only one day for me to just, or any auditor to walk around the college, see how it is used, what are the type of equipment that you're using, whether your air conditioners are 5-star label, whether you use LED lights, whether your fans are BLDC, or there are many, many things that we can just look and find out whether there is a scope for improvement. So walkthrough audit is carried out without doing any measurements, but just by observation, and that requires a little bit of experience. You cannot do it just by taking some formula out of the textbooks. Preliminary audit is actually something where you make some kind of basic measurements or what is actually how much energy is consumed per day in your house, or how much energy is consumed per day in your college building, whether there is any difference between the energy consumed in your seminar hall on this particular day when there is a seminar where all the students are sitting, and the energy consumed when the number of students in the hall is less. And there are many, many things that you can make a measurement in the preliminary audit and make an analysis. Detailed audit is actually a very in-depth analysis. It is not just a one-time snapshot reading. You might make 10 or 15 types of different readings at different time, different climate time zones, or whether the weather changes. All these things will be done. If you go to industry, you do an audit even on the production methods, how all their resources are used, and it's a very detailed audit. At least it will take around 10 to 15 days even in a small industry. Investment grade audit is something where the auditor puts the money by himself. If I am the auditor, I'm coming to your college and saying that your seminar halls has got the air conditioner which is less efficient, and I'll tell you if you move. I'm just telling as an example. I don't know what type of ACs you use there, but still, if I say that your air conditioner is less efficient, then I will say that I will put the money. I will change it to a more efficient air conditioner. Whatever saving that you get out of your electricity bills, please share it with me. That's a type of audit which is called an investment grade audit. It's also called ESCO, energy service companies who do that. And now we are actually propagating a little bit more uh, detailed study called a resource efficiency audit. It's not just about energy. It's not just about electricity. It's about the total resources that you're using. Probably if I'm coming and doing an audit in your college, I will be looking into how much of paper that you use, whether you can reduce that paper, how many people are traveling by their own individual vehicles, whether you can have a public transport which can change that consumption pattern. And it depends upon the entire resources. And now for the NAC accreditation, many of the institutions are doing this green or carbon neutral audit, which is similar to almost similar to the resource efficiency audit, but it will give you an idea about how you can become a carbon neutral or net positive energy source. So these are all just to give you a glimpse of what are the different types of energy auditing. And whatever may be the type of audit, you are actually looking into understand the cost of energy, comparing yourself with maybe with another institute or yourself with another one building to another building. You understand when the energy is used and where the energy is used. And also the ultimate objective is to eliminate waste, maximize efficiency, and optimize energy supply. So These 7 steps are mandatory whether you're doing any detailed audit or preliminary audit or investment grade audit. Uh, we'll understand it when we go through our examples of our own house. So just think about it. What activity consumes maximum energy in your house? If you have a book and a paper, just note down this number, whether it's cooking, whether it's heating, ventilation, air conditioning, or whether it's refrigeration, whether it is lighting, pumping, transportation, and others. Sorry that I can't, I'm unable to get your answers here. Actually, that's why I told your principal that it's always better that we have an offline discussions. Then we can actually clear. If you have, just put this number in your mind or in your paper, in your house, where or in your institution. For example, let's take only the house for the time being. Where do you consume maximum energy? If you don't know where you consume, you'll not be able to conserve. That's what is being told. You cannot conserve what you cannot measure. Since you are not measured, I'm just asking you a gut feeling, whether it's cooking, refrigeration, heating, vending, air conditioning, lighting, or pumping. Just note down the number. We'll discuss it. Then also, if you look only into the electrical energy, which equipment is consuming maximum energy, whether it's air conditioner, fan, refrigerator, luminaires, or the lighting fittings, pump, iron box, geyser, grinder, washing machine, television, computer. You might have some idea about this, whether you have measured. If you have measured, you probably will have the correct answer. But if you are not measured, probably you will have some idea about which equipment is consuming maximum energy in your house. Just note down that number also, whether it's 1, 2, 3, up to 11, any one of them. Now let's start an energy audit. Starting of an energy audit is to understand what are the common sources of energy in your house. It can be LPG, it can be wood, it can be biogas, it can be kerosene, electricity, diesel, or petrol. So which source is consumed maximum will tell you where do you consume maximum energy. And how will you compare? If you want to compare, then you should have a common parameter. You can either convert it to a kilocalories or joules. For example, 1 cylinder of LPG has 14.2 kilograms. 1 kilogram of LPG produces 10,000 kilocalories. So that means 1 cylinder will have 1,42,000 kilocalories. 1 liter of petrol or diesel is around 8,800 kilocalories per liter. And 1 unit of electricity is 860 kilocalories. So convert everything into kilocalories, and then you will be able to come to a common unit of measurement, and you will be able to say where do you consume maximum energy. And for electricity, you need to calculate how much energy you use. This is for a house which uses 160 units bi-monthly, where there is no air conditioner inverters. Actually, this is my own electricity bill, which will show you that bi-monthly average consumption is around 150. Now it has increased after COVID. This is before COVID. So I was just trying to measure what is my consumption. The geyser consumes 10 units, iron consumes 5, refrigerator 20. And I found that the fans consume maximum energy, that is 45 units. And mixie 7, TV 6, washing machine 35, water pump 5. So it all adds up to 160 units. And the most important learning from here is that fan consumes maximum energy. If you don't have an air conditioner at home, all your houses, the maximum electrical energy will be consumed by the fans, not your geyser, not your iron box, or not your refrigerator, most often. This we can find out and measure and see. So I'm just making a comparison of 3 sources of electricity, LPG, petrol, and diesel. These are the 3 major sources of energy in my house. My average measurement, I took it as 100 units per month, even though it's 160. Now it is more than 100 units. So I took it as 100 units per month. So I converted everything into kilowatt hour instead of kilocalories. So 100 units is 100 kilowatt hour. That means the cost is somewhere around 500, 600 rupees. LPG, I use 1 cylinder per month. It is equal to 165 kilowatt hour. Weightage is 32%. Cost is around 900 rupees. But I consume 25 liters of petrol and diesel. Equivalent is 250 kilowatt hours. And It's 49%. That means in this house, the maximum energy is utilized for transportation, for your petrol and diesel, and you pay maximum money for that. 2,500 rupees compared to around 1,000 rupees for LPG or 500, 600 rupees for electricity. So this is how we start doing an energy audit. Now you understood that where do you consume maximum energy, where do you spend more money on energy, and now you can start thinking about how you can conserve energy and manage energy. So this is the first step of doing any energy audit anywhere, whether it's in industry or in your house. Try to understand what are the sources, how much you consume in a month or in a year, calculate, compare it, and also understand what is the cost. Now, I'll give you an, an insight about the carbon footprint also before we go into the discussions and questionnaires. Uh, I am sure that you know about what is meant by carbon footprint. You convert everything into the equivalent carbon dioxide and understand all these transport of waste, electricity, personal use, gas, everything. So what I did is, I told you that my average bi-monthly consumption pre-COVID was 146 units. And after post-COVID, it became 288 units because I was sitting at home, putting lights and fans all the time. My daughters also was at home. So I had an increase of 71 units per month. This can be converted to an approximate carbon dioxide emission of around 55 kilograms. My wife, who used to pool car, that is, four of them were sharing cars every day to go to the office, had to drive her own car every day. Um, so her consumption has gone up by around 30 liters per month. Instead of 10 liters, it has gone to 30 liters. So for this 20 liters, I calculated what is the equivalent carbon dioxide. It's around 45 kilograms. So mind you that myself and my daughter sitting at home contributed more carbon dioxide than my wife who drove to her office every day. So normally people were, there were some discussions showing that during COVID, since people were not driving, the carbon dioxide emissions have come down. But actually we have produced or contributed more carbon dioxide by sitting at home. In my case, it can be different for different people. So what I found is post-COVID, I have approximately added 100 kilograms of carbon dioxide per my family per month. So this is what you meant by carbon footprint. So my carbon footprint has increased by 100 kilograms per month. This is how you can calculate for your industry or for your institute or when you're doing a carbon neutral study. Now, I'll just share with you some of the tips for energy conservation. I, I told you that fans consumes maximum energy in your house most often. So the conventional induction motor fans consumes around 70 to 80 watts at full speed, whereas the brushless DC fans, the BLDC fans, consumes only 28 watts at full speed. And this brushless DC will consume only 10 to 15 watts at low speed. So converting your induction motor fans to BLDC fans can actually save your energy by 1/3. I told you that there are different sources of energy at your house, and one of the main energy source that you can have is your biogas plant. Your kitchen waste, your wastewater, or even your toilet waste can be converted into biogas, and you can use it as a cooking medium so that your LPG consumption or your electricity consumption can come down. Using pressure cooker, this is a challenge for mainly for mechanical engineering students who are going to start learn about boilers. I want you to learn about how and why the pressure cooker becomes more energy efficient. And is it right to operate the pressure cooker by allowing it to release its pressure by allowing it to whistle? Normally people cook using the number of whistles. For example, for chicken, there will be 5 whistles. For dal, it can be 2 whistles or 1 whistle. This is what's happening across our kitchen. People count the whistles and then decide how much time it takes to cook. But ask and or think whether it is the right way, because the moment you release the pressure inside the cooker, what is happening to the temperature? Is it the right way, or do you have to allow the pressure cooker to whistle at all? And if you go to an industry and ask them whether will you allow your boiler's safety valve to pop, they will definitely say no. We will never allow our boiler safety valve to pop. then why should we allow this small boiler in our house to pop every 5 seconds? So discuss about this. I'm not going to give you any right or wrong answer to this. And avoid remote switching of idling. I've seen many areas where the laptop chargers, the mobile chargers, even the computers and the TVs are switched off in remote. Or the laptop, the charger will be plugged in and you will take the laptop and go to the college. The moment you don't switch off, it adds to a phantom power. And that's a very huge amount of energy in the institutions. And we found that we consume maximum energy and we spend maximum money for transportation. So if you are driving your own vehicles, a car or a bike, I can tell you that by adopting good driving habits, you can save at least 20% of your energy. Or if you can check your tire pressure regularly, that can reduce your energy consumption in a huge way. Adopt carpooling or vehicle pooling, two-wheeler pooling. If two people are going the same road, share your vehicle so that you can reduce. Use public transport as far as possible. Why I'm stressing on these three things is that we found that we produce maximum pollution through transportation, and also we use maximum energy in your house for transportation, and we spend the maximum money for transportation. People who are driving, switch off your engine on red. Nowadays, you have that numbers coming. Whether you have 5 minutes, whether 30 seconds, 60 seconds, or more than that is remaining. The new generation vehicles, if your batteries are kept proper and if your vehicle is properly maintained, then there is no doubt that you can switch off the engine and start it when you have 2 to 3 seconds left out. And AC temperature, I don't know how much temperature is set in your hall now. For the climate conditions like in Kerala, 25 to 27 is a really comfortable temperature. If you reduce this temperature by 1 degree, for example, if you, instead of 25, if you're setting at 24, you're actually going to cause 6% more energy consumption. And many places I've seen people are setting it at 16, 17, 18 degrees centigrade, thinking that the moment you reduce that set temperature, the room will become cooler faster. That's a very, very wrong concept. The moment you put it in 16 and 17, the compressor will never get cut off and you will consume more energy. Every 1 degree can save 6% of energy. And I'll give you one simple example from the industry side before closing. It's about the motors. 70% of the electrical energy in industries are consumed by motors. But very few people know that the running cost of the motor is almost 90%, 97% than its initial cost. And there are studies which says that if operated on a high duty circle, the capital cost of large electric motors can be less than 3% of lifetime operating cost. What does it mean? If the efficiency of the motor is increased by 1%, then you are going to save a huge amount of money. If somebody is selling you a motor with 85% efficiency, and other one says that you pay me 10% extra money, I will give you a motor with 90% efficiency. This 5% efficiency can make a big change. Think about what is happening in your house. When you're putting a pump for pumping water from well or to the underground tank, you buy a monolithic motor pump plus pump from a local market. You don't know the efficiency of that. Gently, it's all these low capacity motors are of very low efficiency, but there are motors available which is having high efficiency, and that can save you quite a large amount of money. But why is this not happening? What are the barriers? That is something that you need to study in your syllabus. And there are a study run by Lawrence Berkeley National Lab in California, which says that if the projected saving of 13% by motors is achieved, then it can lead to a reduction of 200 million tons of carbon dioxide every year. It's not a small amount. It's almost equal to 2% of China's or 5% of USA's or 8% of India's annual carbon dioxide emission. Just by changing motor to high efficiency motor, you can reduce 8% of our annual carbon dioxide emissions. But why people are not doing it? Lack of legislation. And only very recently, India has banned the low efficiency motors in the industrial sector. Low efficiency motor. And normally people pay increased attention to procurement price, the first cost. They don't really look into the life cycle cost. I told you, if you look into the life cycle cost, the energy contributes more than 90%. Inadequate and outdated skills leading to system oversizing. Engineers generally have a tendency that you put a factor of safety to each and everything. So if you want a 10 kW motor, we will say, okay, let's go for 15 kW motor. What is going to happen? But this oversizing is actually causing a reduction in efficiency. Missing replacement culture and inappropriate recoiling. Think about your own house. If your fan fails, you'll immediately take it for rewinding, for which you need to pay only 500 rupees. A new fan may be costing 1,800 rupees. But the moment you rewind that fan, if it is consuming 70 watts at full speed, it would have gone up to 100 watts at full speed after rewinding. And within 1 month, your electricity bill will shoot up. So instead of that, why can't we think about replacement with a BLDC fan the moment it fails? And market failures and barriers like higher initial cost. For example, BLDC fan costs around 3,300 rupees, whereas a normal fan costs 1,800. So there's a barrier of initial cost. But still, if you're thinking about the life cycle cost, definitely you will be replacing it than repairing it. And there are many other economics factors called transaction cost, principal agent dilemmas. I'm not going into it. But why I'm putting this here is, you must understand that if you want to become an engineer, you also should understand what is economics and what they talk about. What is the behavior of the people? You must understand what is the transaction cost. What is the principal agent dilemma? Not that as engineers we need to study only that Fourier series or the Laplace transforms or differential equations. We also need to understand what is happening to the environment around us or the economics by which the society is driven by. We cannot continue to do what we have always been done. If sustainability is to be achieved, we will have to rethink virtually all our industrial process or all our process, energy using processes. Sustainability is balancing not a company's financial, social, environmental performance. It's about balancing your house's financial, social, and environmental performance also. Energy efficiency complements resource efficiency, and in many manufacturing units, material costs are 30 to 80% of this cost of producing a product. This is where I told you that the concept of embedded energy comes in, where you must understand how much energy goes into the production of any material. For example, if you are using concrete for building your house, and instead of that you are using red bricks or you are using mud bricks, what is the difference in energy, the embedded energy that goes into it? You build big concrete jungles and put LED lights and say that I am going to save energy. It may not probably make any sense. So for that, you must understand energy efficiency complements resource efficiency also. This is something that we have done in the Puthanvelikara Panchayat for the last 1 year, where a college very nearby, civil engineering, finally a civil engineering students at Puthanvelikara Panchayat carried out a flood level mapping. They said for the first time in their course, they went out to the public and studied something that is very useful. Now there is a flood level mapping for the Puthanvelikara Panchayat done by a group of engineering students. They started from this great trigonometric survey benchmark in the British East India Company in 1887. And this is how that you have to contribute something back to the society. And we have installed a rainwater gauge, river water gauge, and also groundwater gauge in the Puthanvelikara Panchayat, and where the school students are collecting data and transporting it to us. And we have made a web platform where everything is available online. And this is an area which is always affected by tidal floods. And this is an area where the 2018 and 19 floods had caused a big devastation. So these are the jobs of engineering students. Don't think that this is something that somebody else had to do. We need to understand how this climate change is affecting the people living around us. Now, I'll it's almost 1.5 hours. So I will put out a few questions before you for you to discuss. Probably we can discuss after this if you want, or otherwise you can discuss with your friends and teachers and find an answer to this. Do you have a solution to address the climate or energy crisis today? Everyone is asking. The moment you say that we are in a crisis, we have a problem, people are asking what is a solution. For example, I showed you a photograph of Kumbalangi. The moment I put it on my Facebook or discuss with people, the first question that came to us is, what is the solution? And we told them we don't know the problem. If you don't know the problem, how can you find a solution? We don't know the real problem of what is happening here. So it takes time. It takes, you need not have to give a solution to every problem the moment you find that. You need to study it. You need to understand it. We need to understand from where the water is coming, at what time it is coming, when it is coming, what is the tidal level increase, how it is connected with the entire climate change issues, and whether there is any solution of building houses on a little higher elevation, or there are many things that we need to study the moment you talk about solutions. So if you think that you have a solution to address energy crisis or climate crisis by saying that, okay, by moving into renewable energy, we will solve, no. So every local problem has got a local solution, and every local problem should be studied in its local sense, and then only you can provide solutions. You cannot have a solution that is applicable in Bihar directly adopted in Kerala without making any study, or any part of the world for that matter. Why is it important to know about the embedded energy? I told you a little bit about that. People are ignoring this very important concept. If you have put in, I'll tell you one simple example that is given by a person called Amory Lovins, who is known as the father of sustainable development. He's a great scientist. Once he was asked in an American Senate, Mr. Lovins, how can you define sustainable energy? He just said, go and ask a chicken or a hen. And people really got agitated, angry, saying that, what are you talking about? And he said, what are the different ways of making building blocks? You can make bricks, you can make, cut into bricks and use it. Limestone. Earlier days, we used to use limestone as building block. You can cut limestone into bricks and then build houses. And later we studied that there is a better method, heating limestone and adding a few materials. You can make a thing called cement. We invented cement, and now you can make hundreds of Burj Khalifas using cement, which is very strong. And that is how you can make a big houses. But he said, weight by weight, eggshell is stronger than cement. Weight by weight, eggshell is stronger than cement. Go and ask a chicken or a hen, how can you make such a strong material without putting too much of energy into it? What I'm saying is, if you want to make a cement, you have to heat it up to 1500, 1600 degrees centigrade. You're putting so much of energy into it, making a material which is very strong, but the chicken can make it equally strong material without adding any energy into it. The similar example is applicable to cobwebs, which is stronger than steel sometimes. So there is no point in putting so much of energy and building a material which you call it's very strong or very useful. But if you make an analysis of how much energy it goes into it, that's why I said the civil engineers have got a big role to play for strength, or for any other matter. If you're continuing to use cement, which is a very high contributor of greenhouse gases, think about an alternative where you put little less energy and bring out material which is strong enough to build your houses. And at your home, very often you hear that people saying that switch off refrigerator during peak hours. Think about whether it's advisable or not. What is going to happen if you switch off the refrigerator? Whether the material inside will get damaged, whether it is going to add more energy to it, whether it's going to cause health problems. You cannot conserve energy by causing health problems. And the one thing that I told you is counting whistles of the pressure cooker the best method. These are something for your food for thought. And another third one is induction cooker a better choice than LPG stove? Earlier days, we never used to tell that use induction cooking, but now we have changed a little bit. The moment you have a solar PV on your rooftop, probably induction cooker is a better choice. But if you're using electricity from which is produced from coal or natural gas, maybe induction cooker may not be a better choice than LPG. This is where you have to understand what is the carbon footprint. So these are some of the questions that you can deliberate, discuss, and find out your own answers. The interactions do not end here, though I pause. my presentation now. You can have, if you have some questions, the teachers or somebody or the organizers can get some questions and ask me, and we can discuss a little bit. And this is one organization that I started a year back called Equinoct with Dr. C.G. Madhusudanan, who is an expert in hydrology, who in fact predicted that Kerala will have dam-induced floods in 2018, 1 month before, and informed all the authorities that we need to take action, but nobody listened to it. This is where the engineers should uh, uh, make our presence felt in the society, saying that people will listen to you. He has done a very meticulous calculation and said that with all data, he said that this is going to happen, but nobody listened. And we need to get the provide science-based solutions addressing the impacts of climate change, working with communities and institutions. So thank you very much, and floor is now open for discussions.
I found that it's really an amazing presentation from your side. And you also started with the opening remarks saying that Maldives may not survive for not more than 10 years. That's really a shocking message. And also during the presentation, you just touched upon the energy auditing. Probably I would expect that maybe after this, our discussions, we can more elaborate to some of the students, possibly.
So we can have a one half-day session entirely on energy auditing. Probably I prefer it to be on offline, coming down to your college.
Yeah.
Because if I don't get a feedback, I feel I'm not happy.
Yeah. That we are also feeling that, because now that era of completely online is changed, and since November onwards, we are into offline mode. So we'll take some questions from students, but I'll be happy to do a separate session on the energy auditing. And
I'll be
also,
happy to come back.
yeah, and also you mentioned about the electricity bill, closely looking into that. Recently, it was happened that I was observing some of the corporate bills, where some of the components was very astonishing. And again, there was a lot of improvements was easily possible in terms of larger money also. That whatever you said is really right. And also, as I have some industrial background, we never see that any of the pressure safety valves, PSVs, are popping in any of the industries, even 1 year, 2 year, 3 year. We deliberately take it to a PSV workshop and we'll do it a calibration. That's the only time it pops up.
Yes.
Whereas, and I don't know how many of the students knows that there are two PSV valves, safety valves in our pressure cooker.
Yes.
One is the pressure safety valve, and the second one for my student, that is a temperature safety valve. Both are there, and we don't entertain that it should not happen. So how the energy can. And also you mentioned about the driving habits. I'm not picking up all the points, driving habit. And again, just some of that is new automobiles. If you have a new behavior in driving, it may average maybe 12 to 13 kilometers per hour. Whereas if you do a very decent, very controlled way of same vehicle, I have a practice to taking to more than 20 kilometers per hour. So what exactly you mentioned about is proven in our case, other than the environment itself. And also you mentioned about the AC temperature, where 6% of that I already, I know about that. Usually maybe 25 to 26 degree may be very comfortable in our case. But we have seen that 18 degrees, 20 degree, people are assuming that that's another. And also you mentioned about that is applicable for all the engineers, which is the oversizing in design.
Yes.
That is a fact. Always we say that the factor of safety. But again, regarding to the ISRO and all, they are not even allowed to have extra factor of safety. That is, I'm just making the point.
Yeah.
So they need to work out the factor of safety very close to 1.0 something and all. So that is where the real challenge of an engineer comes, irrespective of the branch of engineering. And also you have given a lot of insight for the final year projects for all the branches of engineering, which I'm sure that maybe these are all final year students. Maybe we'll take an opportunity, like the pre-final year students now, they are on the examination and all. So they'll be coming back in the campus within 2 weeks time. So I'm sure that that will give the insight for them also. And lot of other examples and insight you said about this. And again, the fan you mentioned about that need not have to replace all the fans at that time, but at least there may be 2 or 3 fans in every house, which is most frequently used.
Yes.
That is where
bedroom fans.
Yeah.
You need to replace only the bedroom fans.
Yeah, that is the most frequently fans. We can identify 2 or 3, one, and at least you can experiment and get a feel of how much is the cost saving. And which you mentioned about some of the companies, which I'm also aware of that. They will take on board, do a energy audit, then they say that whatever extra bills comes, we'll do everything. So that is another initiative. Possibly you can just a little more elaborate on this. Over to you, sir. And are there any other questions to the audience from the APJ hall, please, Dr. APJ? Over to Dr. Tolos or other, please.
Your presence and wise words help magnify our cause in the best possible way. Thank you once again. We'll move on to our interactive section. Do we have any questions from the student side?
Yeah, somebody is raising hand.
Good morning, sir.
Good
I'm
morning.
Akshara from Civil Engineering Department. And my question is there any funding agencies available for the project work and researchers in the field of energy management and conservation?
There are, but my question is, why do you want a fund for doing your engineering projects? It's not that expensive to do some very simple basic studies. There can be, if you are looking for a global change or something that is coming out with a new product or something, then only you need to look into the funding. I think there are enough and more areas where you need to study the fundamentals of where you can contribute as a graduate engineer.
Thank you, sir.
And
Oh,
I
you don't
think
have any
that
other questions? Yeah.
being the difference between the energy before consumption and after consumption, and that way that you may be able to even start a startup so that you can make the revenue by yourself rather than going a funding external one. Jayaram sir, do you agree on this?
Yes, perfectly, sir. So what I was telling is people don't think about funding when you're talking about the projects. Think about the problem first, understand the problem, then let's see whether it requires funding or not.
Okay. Next question, please.
Any more questions?
Buildings are going to be the most important area for energy conservation in the coming years. I think you need to study about energy conservation building code and what are the areas for improvement as a civil engineer. I'm happy that a civil engineer asked this question. Good.
The second question, sir.
Yeah.
Good morning, sir. I'm Devjindana Kaya from Civil Engineering Department. I would like to ask that what are the factors affecting the energy audit when it comes to
Factors
practice?
affecting energy audit or factors
Yes,
affecting energy
barriers.
consumption?
Energy audit barriers affecting.
Barriers of energy audit as such is our mental barriers. If you are willing to do an energy audit, then absolutely there is no barrier at all. There is nothing that stops you from doing an audit. And maybe as in a college, what you might is you may not have enough equipment that can measure certain things, but that definitely we can arrange from other areas. So there are not so big barriers as far as you are concerned, but as an energy auditor, as a business, definitely there are a few barriers, because even now people are not paying enough money to these people who do a big job and do the audit, and that may be a barrier. But for you people, there are absolutely no barriers. If you want to do some measurements, get help from other industries or other people, we can definitely make some arrangements for that.
Sir, I think the question may be generic on the implementation of the barriers.
Okay, implementation of the barriers. Do you mean implementation of barriers? I'm really happy to talk about it because that was my PhD thesis.
Yeah. I think that is a question, I believe.
Okay, that is the question. I think.
And again, it is not as a student. I think she is asking about as a corporate auditor.
Okay, great. Yeah, implementation of energy audit recommendations. Yeah, there are quite a number of barriers, not just in countries like India. My part of the study was based in US industries and part was in India. And I found that even in US, 50% of the recommendations given by an auditor is not implemented. And people think that it is because of it is not financially viable or economically viable or technically not feasible, but that's not right. We found that the major barrier is behavior, and that was my thesis also, that if you can change your behavior, then many barriers can be removed. So that is why I said that if you have develop some insights about energy and energy conservation, then half the job is done. Then solutions will come. If you know why, how can be found out. Industry also, I've worked in industry for 25 years. I know that there are many barriers like change aversion. People are not willing to change. People are not willing to adopt new technologies. Even in your house, if you look into it, you can see that there are a lot of behavior barriers. Technological barriers are there a little bit, not much. And economic barriers are also there. Some of the, as I said, the BLDC fans are a little bit costly compared to the induction motor fans. So there is a small barrier called first cost barrier or initial cost barrier. So these are some economic barriers. So major barriers are behavior barriers, and add on to that, there are some technological and economic barriers. And that's our challenge. As engineers, we need to find out solutions to these barriers. Good. Sorry, I got confused with the question. Thank you, sir. Sojan sir, for
Thank you, sir.
clarifying.
Yeah, thank you, sir. It was good.
Any more questions?
Sir,
Yes.
energy use in building is 17.5%. And the use of civil engineer, what can be done by use for reducing the emission and to save the world?
Absolutely good question. Thank you for that question. And you have noted down that energy contributes in building contributes around 17.5% of the greenhouse gases. Uh, what I suggest is that you can just go into a document called Energy Conservation Building Code. It is called ECBC, which will give you some ideas about how we can actually reduce the consumption of energy. One example, what Sojan sir was telling about changing your fans, setting your temperature of AC properly. And it also includes how you can use the natural sources of energy like natural light, wind. There are some buildings which is constructed in such a way that you don't require an air conditioner. In Kerala, I think if the construction is done in a good manner, there are many buildings which doesn't require an air conditioner because our climate doesn't go, temperature doesn't go very high and very low. So it all depends upon how much how the living space is constructed, and also the material that you use. One example I can tell you is, if you observe that in our most of our air conditioned rooms, here also I can see that we put the curtains inside the hall, and so that you prevent the light coming inside. But the moment you put curtains inside, it doesn't prevent the heat coming inside. The heat is coming. Instead of that, the curtains, if you put some stickers on the, or use special type of glasses, which will prevent the heat coming inside, that can save a lot of energy in the air conditioner. Or you can put some films, thin films on the glasses, which will not allow heat also to come in. It will prevent light as well as heat. But if you're putting curtains inside, it will prevent light, but it will not prevent the heat coming inside. So there are very, very small things that you can do in the construction, or allow the natural light to flow if it is not an air conditioned room. Use the materials which uses very less amount of energy, and construction method also. I hope I suggest you go to the book Energy Conservation Building Code, which is available free on website, and they have hundreds of suggestions that will help you to reduce the energy by building.
And to supplement that question, I think I have one of my classmates, his name is Dr. Yalkesh Sribadi, who has done his MTech and PhD from IIT Mumbai, has constructed his own house, and it is always cooler than at least 3 to 4 degrees centigrade than the outside. So possibly any of the students wants to get in touch with him. He has constructed it long back and it is still doing. And also, I think at least 20 years back onwards, he was converting the solar energy for cooking also. So he barely used. And also 100% he is using only rainwater for his entire house purpose. And again, every month he goes to the town and he takes the readings and he get it certified. So that initially there was a challenge that he is using rainwater. So all these things just for the information of the students. Thank you, sir.
Thank you, sir. Thanks for the point. Yes, sir.
I think if there is any more questions, otherwise we can even go later on also. The time is also coming up. Jayaram sir is having another session after 11 o'clock. So, sir, anyway, Jayaram sir, it was really nice, and I'm really glad that students were asking a lot of fundamental
Yes, sir.
questions,
Yeah.
and that itself will trigger a lot of insight thoughts. And again, civil engineering students, particularly, they have this subject in their final year as an elective also. And really glad that all the students are very active and asking very fundamental questions. I'm sure that this will be more live if it is face to face
Offline.
also.
Yeah,
That
sure.
opportunity also will see. I think over to Dr. Paulos for your over proceeding for the next session.
Thank you, sir. Now, I would like to call upon Dr. Paulos, sir of Mechanical Engineering Department to propose the vote of thanks. Over to you, sir.
Thank you, Anu. Distinguished guests and beloved audience, I am hereby authorized on behalf of MBETS, management, staff, students, to convey my vote of thanks to everyone present for the session. First, my hearty thanks to our resource person of the day, co-founder and the MD of ICNOCT, Dr. Jayaram sir, who has made us aware and educate us on energy conservation and its importance for the future. Sir, I can assure you that this day on MBET's diary will be a memorable yellow page. Thank you, sir. Next, I thank Secretary of MBET's, CA Kunyachan, who provides us the necessary support for the event that we propose. Thank you, sir. Our principal, Dr. P. Sojandal, sir, our motivator, our mentor of mentor, our inspirer for all the activities. Thank you, sir, for the coordination of this meeting for us. I thank HOD Mechanical Engineering Department, Vidhi Shaldo Baby, HOD Civil Engineering Department, Manju George, for your special support and guidelines. Last but not the least, I thank other department HODs, teachers, non-teaching staff, program coordinators, which includes comparers, sound and video controllers, joint coordinator Elias sir and Veena miss. With you guys, this program won't be a great success. Thank you all and have a wonderful day. Thank you.
Thank you, sir.
Thank you and see you.
Okay, sir. I request all the students to remain seated. Nidhi sir has something to share with us.